This is House Planning Help episode 65. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're looking to self-build or renovate. I'm exploring what houses we should be building in the 21st century. My personal goal is to create an energy-efficient home before I turn 40 in August 2016. Coming up in this session, my guest is Alan Budden from Eco Design Consultants, and we're looking at how simple design decisions can drastically change energy performance. More on that in a moment. Alan is also one of our corporate backers for the documentary we're making. It was funded on Kickstarter and it's called The Future of Housing. So we're currently underway with that at the moment. There will be a slight delay because, as I mentioned in the last episode, my son arrived. Actually, quick update on that. He not only arrived very early, but he had to stay in hospital for a while. Now he's back at home, and what's very odd, if you're a parent, maybe you can relate to this, that it all feels very natural, and I almost can't imagine life without him, reverting back to that other situation. So we're having a blast here. Although I will say this, it's really worrying how much you send to landfill. I probably should do a bit more research of more environmentally friendly ways of, instead of wet wipes and nappies, and you're just constantly building up all this stuff and chucking it in the bin. There's no other way to do that. And I noticed that in the hospital as well. Everything, of course, it has to be sterilised in that environment, but it just gets sent to the incinerator. And the flip side's not working. If you look at something like breastfeeding, it's very natural and you don't need to sterilise the equipment compared to buying plastic bottles, sterilising kits, warming that milk up, all of these things. So yeah, some more things for me to think about. Slightly off track though, because I know that we're podcasting about housing and I don't intend to move on to babies just yet. Yeah, that could be another idea that I'll come up with. You might not think that you need to know about the design of your house because you're not going to be doing that. But I really feel that it helps to at least get your head around some of the important aspects. And that's why we're chatting to Alan Budden from Eco Design Consultants today. I discussed with him what we might think would make a really good episode, and he suggested just going over a few basics and trying to understand their impact. We're not going to talk about scale today. It's that similar thing that the scale is so important. If you have this huge great house, make it an eco house, it isn't really an eco house. So we're going to talk about a few other design decisions that might be made along the way that could actually impact on energy performance. We can also bring in How Park, which is one of Alan's key projects. I think it's the most airtight structure that's been built in the UK. He'll have to correct me as we get into this. And another thing that I want to bring up just towards the end, because I went to the UK Passive House Conference a couple of years ago where he was giving a presentation, and it was actually based on How Park and looking at what was the likelihood the MVHR system conks out and you don't notice, and then that you might suffocate in there because of the CO2 buildup. So we're going to address that at the end. Maybe something that might have crossed your mind, who knows? Anyway, we got things underway. I started by asking him about his background.
Okay, I've been interested in buildings and architecture since I was a kid and trained on to be an architect quite early on. Been very interested in housing and really trying to improve people's social well-being. Then I taught architecture in Sri Lanka for a little while, and then I came back to the UK and did some light gauge steel. But again, I was very interested in the environmental things and I'm pushing forward things. Became an eco-homes assessor to start with, and then that developed into Code for Sustainable Homes, and I became an associate at PHPP Architects. Developed a little bit more there on the low energy housing stuff and designed one of the country's first 5-star houses down at the BRE Innovation Park. Then after that, I set up our own practice 5 years ago now called Eco Design Consultants. We really did look much more at the building fabric as the first approach, potentially adding on renewables if necessary. I then came across the Passive House standard. Ever since I came across it, I've been hooked. And I think every person I speak to, it just makes so much sense.
I'm quite interested in our chat today to talk a little bit about some design decisions that make a big difference, but you're also dealing with the client side of things as well. So it's going to be quite an interesting episode, I think, as we reflect on a few of those. So I come to you as a client. What are the first steps that you'll be doing with the client?
The first step with the client really is to understand what they want, what their wishes are. I mean, trying to get under their skin. Not necessarily just to understand how they're living at the moment, but how they would like to live, whether it's open plan, whether they have any particular interests or stuff, whether it's maybe they've got dogs and outdoor life is very important to them, so they need somewhere where the dog can sleep and can be washed and without mucking up the whole house. Or it could be laundry. We have one client where laundry was an important part of their lifestyle, and the laundry room was to be in the centre of the house so that they could see everyone.
Fantastic. Would they have a plot at this stage, or does it just vary?
It varies. I mean, hopefully they have got a plot, because plots are incredibly difficult to find. Often our clients already have a house, and it's often a retrofit. So we'll be looking at whether at that stage they may be doing energy improvements and also extending, and maybe making the house work for them, because there may be bits of it that aren't really very functional.
How often do you have to educate your clients, or do they come well informed?
It's becoming less and less. I think we're getting quite a reputation now for low energy housing, and people come to us because we know passive house and we can understand those things. But we do still really make sure, particularly at the later stages on site and stuff, that they understand the details and they understand the need to attention to detail and making sure the air tightness works and the insulation is continuous. There's a lot of things like that I think we help to, I suppose we push them, but at the end of the day, we also will respect the client's wishes. We're building for the client at the end of the day, not for us. So it is the client's wishes that we go for.
Quite often when you're looking for low energy as well, and I am very much on this process, I'm open to learning, and if I can be told something or educated just that little bit further. And that's why some of these things that we're going to bring up today, yes, we've probably heard about them before, but it might be interesting to go into a little bit more depth, and also just because teaching is another element of what you do. Maybe you should explain that.
Yeah, I should have said that earlier, really. I also teach the undergraduates in architecture up at Birmingham City University, teaching them about sustainability and the technology of low energy buildings. I think it's very important that now they will be building zero carbon houses and low carbon buildings when they graduate, so they need to know from day one. Some of the things that we look at is the building shape, the form factor. It's something that's not really, I don't think, understood by general people, how the shape of the building really makes such a big difference to the energy. For instance, one of the exercises I do with the students is we look at U values, the heat loss to a wall on the fabric, and then we look at multiplying out those areas to a simple house. So we look at a 100 square metre house that's 2 stories. The square house, they discover as we go through the process, has a set amount of energy loss. We then look at an L-shaped house, same floor area as the square house, that has 7.5% more heat loss just through the shape.
Okay, stop there for a moment. So we are saying because there's a bigger surface area of the exterior, and that's just because it's no longer, sorry, I'm trying to work it out in my mind as a way of explaining it and going completely wrong.
Yes, that's exactly it. It is very much about the shape. Basically, you're losing heat out of any external wall. So if you have less external wall, you'll lose less heat from the building. So the simplest shape is probably a sphere, but we can't live in a sphere because that would be incredibly difficult. So the most practical shape is probably a cube. That has the best sort of floor area to surface ratio. That would be the optimum in terms of heat losses. And what's interesting as well, that when we start looking at it with clients, it's not just about heat loss, it's about building cost. The most expensive part of your building is the outside envelope. So if you make the outside envelope smaller, then you reduce your costs as well.
Are there any other shapes that we should be avoiding, or do we just think every time it gets more complicated, the percentage will alter?
Yeah, I mean, it is. Anything you sort of add on, dormer windows and things like that, anything that sticks out will increase your heat losses. It also probably increases the complexity of the build. You'll find that the details around the dormer cheeks and the sides are additional details that could potentially be cold bridgings, could potentially be the areas where air could be leaking out. So it does all complicate things, as well as adding it onto the cost. It does want to be quite a simple shape, but saying that, I'm sure you're all thinking that's going to be really boring. But I think you can, through materials and through adding different bits to the facade, you can still make quite an interesting building.
I know that my wife is always very critical of things when they look blocky and square, and that's why she has this love for older buildings, because they do have lots of little extra bits on it. Where is the balance, and how can we almost keep that shape but add on the exciting bits, if that's a good enough question?
Yeah, it is. And at the end of the day, the building is got to be something that just gives delight and is for the people. If it doesn't succeed in its function and give delight, then the building has really failed its sustainability credits anyway. One of the things I quite like doing is the house I mentioned before down at the BRE, Oxford Brookes University did some monitoring of the house. They had a family that lived in there for 2 weeks every season. And there's a report done at the end of it to sort of how they found it, where they got hot and all the rest of it. One of the interesting findings from there was not about the energy side of it that I found really fascinating, was the young daughter who had one of the front bedrooms. It was the first time that she could see out of her bedroom window, because she obviously was fairly short and couldn't see out. But this window went down to the floor, and that's really struck a nerve with me, actually. And so from then onwards, I've actually thought about that. And Howe Park Passive House, in the top bedrooms, we had a slit window which went down to the ground. And it was very interesting. On the open day, we'd often find little kids sitting there looking out. The interest on that window was we looked at the energy losses and gains of that window. And it was actually losing more heat than it was gaining. So really, in energy terms, we probably shouldn't have had that window. But it provided delight and it provides interest. So it's about having the tools to decide which way you want to go. That's the key.
And that's going to be my next question, as where is this balance, or is that down to the designer, or perhaps it's not, perhaps it's even more down to the client?
I think we work with the client. I mean, one of the things that we do is we often put the building into the Passive House planning package, and from that we produce an options report which has a number of graphs and stuff, so that you can really kind of understand exactly where the losses are, so you can start to balance things up. So in your mind you can see, okay, that's extra dormer window, which is fantastic and nice. Okay, that might lose 5% extra heat loss. Is that something that you want to maybe increase the insulation elsewhere to have and still have the dormer? That's the sort of questions that we'd look with you. Dormers are lovely, and then we shouldn't necessarily not have them, but it's understanding the overall picture.
And I suppose that is it, isn't it? That if you do want something that's a feature, you have to make up for it somewhere else.
Yeah, that's right. It's understanding that loss. I don't think people do necessarily understand the shape, and other things do have a cost and knock-on effect.
Another aspect, our houses need windows, but there is some interesting statistics, aren't there, which I'm just going to let you explain.
Okay. No, windows are really, really important. Probably the least heat loss would be a house with no windows at all, which would be absolutely horrible. We need window for daylight and for delight and for well-being. But the way we design the windows is crucial. We don't want it too big because it will overheat. We don't want it too small because we won't have enough daylight. And the way the window works is also important, because the window frame is probably the weakest point in the whole building. Your U value through the external wall could be as low as 0.1. U value through the window frame is probably 1, so it's possibly about 10 times as worse. So you really want to limit the amount of window frame as far as you can. It's one of the exercises I actually do with my students, actually. We look at a simple window, 1 metre by 1 metre. So we have a nice square window. And then we look at, okay, we split that 1 metre by 1 metre window into one opening and a fixed light, so just a vertical mullion down the middle, and that increases the energy performance by 16%. It's 16% worse than the other one, just purely because it's got more frame, so that's losing more heat, and also it's allowing less sunlight in, so it's not giving you any solar gain. And then if you look at sort of the traditional English window, where you have the window divided in half with the central mullion, and you also have a little opening light to let the ventilation in, that is even worse. It goes up to 28% worse than the square window. So just simple things like that can make quite a difference.
Over the course of the design, is it a case of going back and thinking, well, actually, I want my opening window and this upright slat, but I'm making up for it somewhere else?
Yes.
Is it the same thing?
Yeah, it is very much you work with the clients, and if you understand those things, they can make decisions. What I think often, I suppose other architects as well, don't necessarily understand the decisions they're making in terms of the heat losses and the energy. They don't necessarily understand the whole picture. I think it's trying to explain those that can really make quite a difference.
And how do you decide how many windows you do put in, or how large those windows are?
With that, we can do things called a daylight factor, so we can actually calculate the amount of window size to the size of the room to make sure that there's the appropriate amount. There's various rules of thumb that we can use as well. But it's one of those things, a little bit. People do like a lot of glass and a lot of windows, which is great, but it's about getting that right balance, and that's one of the things that we help them with.
Air tightness, I know, is another one on your list again. We've covered it extensively on the podcast. But coming into this as a client, are they normally clued up on air tightness?
Not always, to be honest. Air tightness is a real passion of mine, and I think it's not necessarily understood. I know when we did Howe Park Passive House that when the in-laws came to the opening day, they were quite concerned, I think, of going into this sort of plastic bag-covered building, and they were going to suffocate, and it's going to be horrible. I think they were quite pleasantly surprised, and they realised actually what I've been saying to them for quite a while was not a problem. Air tightness is not an issue. It reminds me a lot of the very old Everest Windows adverts, where the guy would be standing at the window, and it'd be really windy outside, and he'd close the window and then drop a feather. And really, with air tightness, we're talking about reduction in drafts. It's not this plastic bag that sometimes it gets thought of.
And go through your stats of if you were just doing this to the building regulations and how, the dramatic change. We're talking about design decisions. Well, if you just say it doesn't matter too much, but it will really make a difference.
Yeah, no, I did some interesting calculations on the Howe Park one. If we'd have met Passive House, which has an air tightness of 0.6 and the specific heat demand of 15 kilowatts per square metre, if keeping at that very low energy rate in terms of insulation, we reduced, which we did on that building, our air tightness down to 0.07. That actually improved our energy performance by 17%. And controversially, if we'd have gone to an air tightness of 3, which is thought of in the building industry as a good air tightness, that would have actually increased the heat losses of the house by 86%. And if we'd have gone to 10, which is what building regulations is, that would be 355% more heat losses, which is actually staggering. I mean, you think about these air tightness, and it's so important. I mean, even with a building regulation house now, built to fairly good standards, not quite to Passive House, but pretty good. If you had an air tightness of 10, you would be losing as much heat through drafts as you would through the insulation. And I think most people don't understand that. And it's so important. And it's relatively easy to put right.
Are there any other key points that we should be looking at? We've talked a little bit about daylighting, form factor, windows, air tightness. What is going to make a huge difference?
I think it's the quality of the build. And I think that's one of the things that the more of the Passive House stuff I do, the more I realise how attention to detail it is. And having an air tightness test at the end of the day means that the builder is going to do things properly. Everybody on site is going to make sure there is attention to detail. The insulation is going to be continuous. It's not going to have any gaps in it. The air tightness membrane is going to be there. It's going to work. And the knock-on effects to that is also interesting. The fact that the building is not going to have any moisture going through the wall. It's not going to have moisture build up inside the fabric, which can cause damage and long-term decay and other things. I mean, it's quite interesting on the Howe Park. There was one outbuilding above a little carport that wasn't built to Passive House standard because it was going to be a drum room. And on the snagging after the first 6 months, most of the things to be put right were on that room, which was kind of built by the same guys, but it was just the attention to detail and the quality of the materials and things wasn't quite as good. And I think that sums up, some of the extra benefits you get from it, which you don't think of to start with.
It's funny how often you hear attention to detail. Now, before we completely change things for the end of the podcast, and I have another question for you to answer, retrofit. When we apply all of these things, is that, say, our form factor, you can't really change anything on a retrofit?
No, often we find that you can. We often find that clients who come to us for a retrofit, maybe to Enefit or somewhere, they're usually doing something else to the building as well. They are looking for an extension. They are looking to maybe go up into the loft space and other things. So in those areas you can. Other fairly obvious things, which happens on most houses actually we look at, is things like they may have their front door maybe slightly recessed into the building. That recessed has 3 sides to it, the 2 sides and the top, which is areas where you're losing heat. They're usually also, those areas aren't particularly well insulated. I know one property we looked at where literally it was just a piece of hardboard on one side and a bit of plasterboard on the other, and that was it. By moving that door forward into the front of the building, we find that can make up to sort of 5-10% improvement on the total energy losses. So simple things like that, even with a retrofit where we're changing the form, can really make a difference.
And windows?
Yeah, I mean, again, if you can take out the mullions and things, then that again can improve it. We may look at reducing some of the window sizes or increasing some of the window sizes as well, depending on the orientation, how much sun's coming in, whether it's being shaded, various factors. We can look to optimise the windows and also potentially make them bigger just because it's a lovely view.
Right, let's move this along. It's a question that I'm sure a lot of us will have thought if we're wanting to move into, let's say, a draft-free house. We're thinking about air tightness. In this situation, one day the MVHR breaks down and we're in the house. Are we in danger? Is this a dangerous situation? And take me through your detailed calculations.
Yeah, I must admit, when we first did that house in Howe Park, I was a little bit concerned because it was just so airtight. It's most airtight in the UK, maybe in the world. I think it was one German building that's better so far. But on that, I did some quick calculations. Basically, it's not the lack of oxygen that's going to damage you. It's the CO2 build-up.
Why?
It's a poison, basically, CO2, so it will harm you.
So we breathe in the oxygen and then breathe out the CO2. And then that will eventually... Okay.
Exactly. So the CO2 level will slowly build up. So what I did basically was look to see what would happen if we were producing lots of CO2. And the worst case scenario would be exercising. If you're exercising, you give out the most CO2. If you're sleeping, it's the smallest amount. So I looked at the occupancy of the house, which is a big 5-bedroom house, would be maximum of 9 people. So if those 9 people were in the house and they were exercising and the MVHR had broken for some reason they hadn't noticed and the windows were all closed and they were exercising, they'd have to be exercising for 24 hours before it got to sort of 1.7% CO2 level, and that would be the first time it would become noticeable. It wouldn't be until they got to 2 days and 22 hours and up to 5% that it starts to become toxic and potentially a risk, and they might be having headaches and dizziness and stuff. But I'd guess they might have wanted to open the window by then. I
was just about to say that when something gets like that, you think, oh God, really is it? And you do that at the moment with ventilation, that if something's not good and in here, this room is stuffy, that's the first thing you do, isn't it?
It is. And people have to remember that in a passive house you can open the window. The myth of not opening windows is still out there. But
it will continue to be out there. We'll say it again at some point. And also, what we're not taking into account is that you're talking about people exercising continuously, not leaving the house. Whenever you do that, the fresh air is going to come in and that will reset all of these and you'd have to be exercising again.
That's exactly it. I mean, it's never going to happen, is it, to be honest?
You're talking about a bigger house, but how would that scale down to something that's a lot smaller?
Yeah, it would be quicker, but you'd have to have a lot of people in a very small space. And again, it would just become uncomfortable.
Well, yeah.
It'd become hot if nothing else, someone opened the window.
That would be interesting if you got hot first. Well, excellent. I really enjoyed this, Alan. Thank you very much. Is there a closing thought on anything that we've been talking about today?
I think just some comments from some of the clients is just, why isn't everybody doing this? I mean, the only downside, I think, of the passive house is that from the clients we've had so far is they don't like leaving their house and don't going to stay with relatives and stuff. They find now going to visit relatives kind of uncomfortable when they want to come home soon.
Alan, thank you.
Thank you very much.
As usual, we've been taking the notes for you, and you can head to houseplanninghelp.com/65 to take a look at them. Perhaps you don't normally do this bit, you just listen to me say, go and check out the show notes, and you don't actually go. Well, today I would say there's a very good reason to go, and that's because some of the things that we've been talking about, Alan has these great diagrams that show it in more detail. So if you are struggling with any of these concepts, it's really going to help checking out today's show notes. Also in there, for entertainment value, I've put in one of the old Everest Windows adverts that he mentioned about dropping the feather. So take a look at that, particularly if you're listening from somewhere else outside the UK and you're thinking, what? I've never even heard of these adverts. That might be a good one for you to go and take a look as well. You can leave a comment, all the usual stuff. houseplanninghelp.com/65 for this episode. One more bit of business, and that is that at the start of the year I launched a book on the Snippet platform, and it was called Why Most People Don't Build Energy Efficient Homes. It's something that I did, I put a lot of work into it, and then largely I've just left it alone there. And it's good to see that every month more and more people read it and download it. So that's fantastic. And I've got a couple of reviews that I thought I'd read about the book. So this one is from Tom Wilson in Sydney, Australia. This enjoyable ebook is effectively effective at highlighting the key elements of taking on a self-build project. If anything, I was impressed how this short read got me thinking with the questions that it poses, and it certainly inspired me to think differently. Ben's dedication to promoting energy efficient and sensible building design is a refreshing approach. If you're a fan of the podcast, then I definitely recommend this book. And also Helen Lindsay in Lancashire, UK says, a thought-provoking, succinct and easy to understand source of information for the energy efficient home builder. Perfect for both the practical novice and the aspirational dreamer, this ebook is what is needed to encourage and inspire more sustainable homes, something which is urgently needed. Thank you, Helen. My call to action, therefore, is that if you have an iOS device, because that's what the Snippet app is really designed for, go and buy your copy now. houseplanninghelp.com/year1. Next time, I chat to Stephen Gurney from Ecological Building Systems about how your airtightness could be compromised, where it's likely to fail, if anywhere. Hopefully not, of course. So until then, cheers.